Assistant Professor in RPIIT Technical and Medical Campus, Bastara, Karnal. Today we are going to perform the experiment, that is to prepare and standardize 0.1 molar sodium hydroxide, that is NaOH, by using oxalic acid as a primary standard. So, for performing this experiment, we require some apparatus and reagents which are burette, conical flask, burette stand, beaker, volumetric flask for preparing the stock solutions, funnel and measuring cylinder, and the reagents we require are phenolphthalein as an indicator. This will be used as an indicator which will predict the end point of our titration. And this is oxalic acid, it would be used as a primary standard, and this is sodium hydroxide, that is NaOH. So before performing the titration, we need to prepare the stock solutions, and for preparing the stock solutions we require to do calculations. As we all know, molarity is the number of moles of solute in 1 liter of the solution. So volume of solution would be in 1 liter. So number of moles is depicted by X, that is the mass we have to calculate, or the amount we have to calculate, divided by molar mass, and molar mass for oxalic acid is 63. Molar mass is 63. So X divided by molar mass divided by volume of solution in liters. As we have to prepare 0.1 molar, so here we will write 0.1 molar. This value we have to calculate, that is, it is the amount which we will dissolve in 1 liter, divided by 63 divided by volume. So X would be 0.1 multiplied by 63 in 1 liter. So we get X is equals to 6.3 grams in 1 liter. So we will require 6.3 grams in 1 liter. But here we need a little less amount of oxalic acid. So we will prepare 100 ml instead of 1 liter. So for 100 ml, what we would use? We will use 0.063. In 1 liter it is 6.3, and in 100 ml it would be 0.63 grams. So now we will look for the sodium hydroxide, that is NaOH. So sodium hydroxide is having molecular mass, that is 40. So we will divide X divided by 40 divided by volume of solution in liters. So X would be 0.1 multiplied by 40. 0.1 is the molarity that we are going to prepare. 0.1 multiplied by 40 equal to X. So X would be 4 grams in 1 liter. So if we want to prepare 1 liter solution, we have to dissolve 4 grams. But if we want to prepare little less amount, accordingly this will get changed. Now we are going to prepare 250 ml, that is divided by 4. 1 liter is divided by 4, then it will also be divided by 4. Then it will be 1 grams in 250 ml. So let's go to prepare the stock solutions of oxalic acid and sodium hydroxide. As we have prepared, this is our 0.1 molar NaOH, that is sodium hydroxide, and this is 0.1 molar oxalic acid. So now we will take 10 ml of oxalic acid in our conical flask. Now we will add 1 drop of this phenolphthalein indicator in this, and we will put this sodium hydroxide in the burette. Now we will start titrating. So we will add drop wise like this. We will add drop wise with continuous stirring. Now you can see a slight color change, slight pink color in this. That means our titration is complete and endpoint is reached. Now we will note down the reading of burette. Here you can see in burette it is 5.5. Here it is 5.5. Now we will note down this reading. We will note down this reading in the observation table. We have used 10 ml of oxalic acid and initial reading in the burette was 0 and final is 5.5. So volume of titrant means 5.5 minus 0, that is 5.5 ml is used. Now for the second, now we will repeat our titration. We will repeat. Now initial reading is our 5.5 and final, let us check for the final. Repeated our titration and you can see a slight color change again. And now our final reading is, you can see here, it is exact 12. It is exactly 12. So we will write here 12. Now our difference would be the amount. Now we will perform again third time. So we will start our titration. We will discard this one. Now we have washed this properly. Again we will repeat our titration third time to get the accurate readings. So we have taken this 10 ml and we will add again 1 drop of phenolphthalein indicator. Now we will start our titration from point 12. This will be our initial reading. Its difference is 6.5 ml. In first titration, our difference is 5.5 ml, that is 5.5 ml was used, and in the second 6.5 ml is used. Now let's check for the third titration how much amount it would take. Continuously we will stir it by drop wise adding. The color will disappear. After a time it will be permanent slight pink color. Now we will check. It is 18. So now our final reading is 18. We will write it here. 18. So 18 minus 12, that is 6 ml. Now we will take average of these three readings, that is 5.5, 6.5 plus 6 divided by 3. So their average would be 18 divided by 3. 6. Their average is 6. So 6 ml is our V2. Now we have to put this in our formula, that is M1 V1 is equals to M2 V2. M1 is for oxalic acid and here is also for oxalic acid. M1 is we have to calculate, M1 is our 0.1 into V1 is our 10 ml. M2 is we have to calculate. In the starting we used 0.1 molar, but now we are going to standardize it. That is, we are checking that the solution which we prepared is actual of which concentration. What is the actual concentration of that compound? So we are taking here M2 and V2 is our 6. So M2 is equals to 0.1 multiplied by 10 divided by 6. So it would be 0.1 approximate. So it is approximate 0.1. So the solution we prepared, the result is approximate 0.1 molar. That is, we prepared the actual amount, or we have prepared nearly accurate amount, accurate concentration. Thank you and have a nice day. If you like the video, please share and subscribe our channel.